Okay, so today we're going to be in section 7.2. And 7.2 is about proportions. I'm sure you have all, whether you remember or not, I'm sure you've all worked with proportions before. And you may have been taught other ways to solve proportions. And there's other methods to solve proportions other than the way that I will show you today. And if you've learned those ways and you're comfortable with those ways, I don't have a problem with that as long as it works. The only reason I'm showing you only this method is because this method works for every single proportion that you will ever try to solve, okay? So, first of all, what a proportion is. A proportion is an equation that sets two ratios equal to each other. So it's basically an equation that on one side there's a ratio, or as we've kind of seen, it's just a fraction, is equal to another fraction. Okay, so to solve these, once again, like I said, there's a lot of methods. The one method we're going to learn is by solving using cross products, okay? And what this will look like is our proportion, kind of our generic proportion, will look like A over B equals C over D. So notice I have a proportion is exactly what it told me. I have a ratio set equal to a ratio. What this cross products idea tells me is that the cross products of this proportion are equal. Okay, well, what's a cross product? If you take the denominator of one fraction and multiply it by the numerator of the other. So you're going to multiply up and across. So B times C would give you BC. That is equal to my other cross product. Okay, so this is a big idea. We're going to be using this for this week and next week. Okay? So multiply up and across, those are equal to each other. We'll have an equation and we can solve. Sometimes it's going to be a really super easy equation. Sometimes it's going to be kind of tough. Okay, so let's just look at some examples here. Okay, so our directions are just going to say to solve. Okay, so first one, I have x over 5 equals 5 over 12. X over 5 equals 5 over 12. Okay, so first thing that I kind of check for, because later on in this chapter, we're going to be given equations that are not proportions. They may kind of look like proportions, but let's double check. Do I have a fraction equal to a fraction? Yes, and just one fraction equal to just one fraction. That's going to kind of be the thing that's more important later on. So if that is true, then I can set my cross products equal to each other. So 5 times 5 gives me 25. That is equal to my other cross product, 12 times x, which gives me 12x. And then to solve for x, what would you do? Divide by 12. So I get x equals 25 over 12. Now you don't have to change this into a mixed number, but if you can simplify it, you need to do that. Is there any common factors between 25 and 12? No, so this would be your answer, okay? Today, if you want to change it to a mixed number, you can, because I'm not asking you for a ratio. So you remember in 7.1, if I asked you for a ratio, you had to leave it like this. For today, if you really want to change it to a mixed number, you can, but it's extra work, so I would probably just leave it like this, okay? Number 2. Yes?
How do you know? So, you always start in the bottom left hand.
So if you wanted to start in the bottom right-hand corner, it would just say 12x equals 25. So it would be the same equation. It would just be flipped. So it doesn't matter which side you start on as long as you multiply up and across. You can't multiply just across.
And then can you, simplify? Change the 5
So,
to 1?
not this way. So if you can simplify a fraction, so for instance, if I could have simplified this 5 over 12, then I can simplify that. But I cannot cross-reduce because I'm not multiplying. They're equal to each other. Okay, if I was multiplying, then yes, you could cross-reduce, but on these ones, no, you cannot. Good question. Okay, number 2. 3 over 4y equals 5 over 7. Okay, do I have a proportion? Yeah, 2 ratios set equal to each other. So multiply up and across. 4y times 5 gives me 20y. And 3 times 7 gives me 21. Solve for y. Divide both sides by 20. Can 21 over 20 be reduced? No. So that would be your answer. Y equals 21 over 20. Okay, questions so far? No. Okay, number 3. Yes?
Which one is, how do you determine your denominator and numerator?
What do you, confused on your question.
Like, which one would be the, how do you, because on the first one, 25 is over 12, and then on this one, it's 21 is over 20.
So for the final answer,
Yeah.
if I'm solving for y, I would have to divide by 20. Right? To solve for x, I would have to divide by 12. It's just solving an equation.
Okay.
Okay, make sense? Okay. Number 3. 15 over z equals 6. Okay, is this a proportion? No, I don't have 2 fractions that equal to each other. Right? That's just a 6. Could I make it 2 fractions? Right, I could say 6 over 1. That means the same thing. Now I do have 2 fractions set equal to each other, and then I can multiply up and across. So I have 6z equals 1 times 15, just gives me 15. Okay, and so if I'm solving for z, how would you get rid of that 6? Divide both sides by 6. Okay, this time I have 15 over 6. I do not have to change it to a mixed number, but do 15 and 6 have any common factors? What do they have in common? A 3. So I can divide out a 3 from my numerator and denominator, and I'm left with 5 over 2. Okay, number 4. Negative 8 equals 9b over 5. Once again, do I have a ratio? What would I do to make it a ratio? Right, negative 8 over 1. And then we can multiply up and across. 1 times 9b gives me 9b. 5 times that negative 8 gives me negative 40. And then divide both sides by 9. Do 40 and 9 have any common factors? What do you think? I don't think so, so I think we're just going to keep it as negative 40 over 9. Okay, we still doing okay? Any questions? Okay, I have 4 more for you guys. Okay, so these ones get just a little bit trickier. We just have to be a little more careful. So number 5, we have 3x plus 1 over 5 equals x over 2. Okay, well, first thing, is this a proportion? Yeah, I mean, that left-hand side, it's a fraction. It's a more complicated fraction, but it's still a fraction. So I can solve this using cross products. You still multiply up and across. So I have 5x equals, but what you have to be careful about is I have to take 2 times that entire numerator. Not just 2 times 3x or 2 times 1. I have to take 2 times that entire thing. So how could I show that I need to take 2 times that whole thing? What were you saying, Marion? Parentheses, which means then we are going to have to distribute. So we're going to put 2, and then we're going to put that 3x plus 1 in parentheses, because that tells me I am going to have to distribute the 2 multiplied by the entire numerator. So to solve this, we would distribute. So 5x equals 2 times 3x gives me 6x. 2 times 1 gives me 2. Okay, I have x's on both sides of my equal sign. What do I do next?
Subtract 2 from 6x.
Do what?
Subtract 2, or I mean, no, put them on one side.
Okay, I need to get my x's in one place, right? Okay, so which side do you want to move them to? You want to move the 5x? Okay, so we're going to subtract 5x from both sides. Okay, 5x minus 5x gives me what?
They cancel.
They cancel out. What am I left with when something cancels out? 0. 0. 5x minus 5x is 0. And 6x minus 5x is x plus 2. And then how would you get rid of that 2? Subtract 2 from both sides. So x equals negative 2. Okay, makes sense? Same exact thing. Just when you multiply your cross products, you end up with a little bit tougher equation to solve. Okay, number 6. Let's try x minus 5 over 12 equals x plus 2 over 5. Okay, is it a proportion? Yeah, it is. This time, I have to be really careful because both of my cross products have a quantity in my numerator, right? So for that first one, I have to take 12 times the quantity, x plus 2. That x plus 2 needs to be put in parentheses. And that other cross product, I need to put that x minus 5 in parentheses as well, okay? And then you can distribute the 12 and the 5. So I get 12x plus 24, and on the right hand side 5x minus 25. Okay, once again I have x's on both sides of my equal sign. Which direction do you want to move them? To the 12x. So I'm going to subtract 5x from both sides. 12x minus 5x gives me 7x plus 24 equals a negative 25, and then what would you do? Subtract 24 from both sides. So I have 7x equals negative 25 minus 24, or negative 25 plus a negative 24 gives me what? Negative 49. Divide both sides by 7, and x equals? Negative 7. Very good, very good. Okay, is this going okay? Hopefully not too hard. You guys want to try one on your own? Okay, it's going to be a lot like the last one we just did. Number 7. And I want you guys to be super careful on this one. Let's try 6b minus 5 over 3 equals 12b minus 10 over 6. Okay, I see a couple people with the right answer. A lot of people are doing the first thing correct and then kind of getting stuck, right? We're going to take 3 times the quantity, 12b minus 10. That's equal to 6 times the quantity, 6b minus 5. Now when you distribute, on the left-hand side, we get 36b minus 30. And on the right-hand side, when I distribute that 6, I get 36b minus 30. I have b's on both sides of my equal sign. How would you get them in one place? Okay, subtract 36b from both sides. What happens? Okay, my b's cancel out, which is important, but what's more important? What am I left with? Negative 30 equals negative 30, true or false? Which means all real numbers. Yes?
That middle step where you took 3 times the 12b minus 10 and stuff, can we just completely skip that step and go right to the next one? Or do you want us to show that step?
I want you to show that step because when they start getting more difficult problems and later on, like in the 7.5 that we're going to do next week, it's going to be nice to see that step. So I would like you to show that middle step. Okay? All right, last one. We're going to do this one together because I put this almost exact same problem on the test that I just gave in one of my other classes, and it was easily the most missed problem, but it was one of the easiest ones, okay? So we'll do this one together. 4b plus 6 over 6 equals 4b plus 8 over 8. Okay, is it a proportion? Yeah. Okay, so I want you guys to go ahead and take the cross products and distribute it out, but then wait before you go to start solving it. Okay, hopefully we got 24b plus 48 equals 32b plus 48. If not, maybe check your multiplication. Okay, now this is the step where people see something in common and they're like, oh, I know what I'm going to do, and they start jumping to conclusions before they don't even solve it, okay? What I notice first is that I have b's on both sides of my equal sign. So, to get them in one place, which side do you want to move them to? Okay, let's move them to the right-hand side. So, subtract 24b to both sides. So, I have 48. 32b minus 24b gives me 8b plus 48. Okay, well, ignore what's on the left-hand side. This is just a two-step equation. How would you get rid of that 48 on the right-hand side? Okay, subtract 48. And what is 48 minus 48? 0. Now, here's the thing. Once people get to this step, they're like, oh, no solution. And I don't know why. Because you can solve this, right? How would you solve for b? Divide by 8. What's 0 divided by 8? 0. Right? Okay, so don't leave it at this step here, because that's wrong. B could be 0. It's not no solution. 0 is a solution. Okay, any questions?